Okay, chapter 1, practice problems number 2. Tell whether the following two statements are equivalent by constructing their truth tables in canonical form. You must explain your answer to get any points. You need not exactly follow the template below. So, is this expression logically equivalent to this expression? The first thing we're going to do to set this up in canonical form is to take each of the variables, in this case P, Q, and R. And we're going to kind of set up, this is going to be a standard way to take the three variables and represent them. So a quick way to do this is just take the trues and falses and divide them out. So the first four spaces being true and the next four being false. Then you're going to go with two trues, two falses, followed by two trues, two falses, and then finally you're going to alternate them. True, false, true, false. And by doing that, you're going to come up with all the combinations of the three variables and what could happen there. So we have all trues, then start with two trues and a false, then a true, false, true. You can see that all those combinations are covered. Okay, the next thing we're going to do are these intermediate rows, and they just basically break this down into pieces. You can see that, well, we need to know what this is, the P and Q. We need to know what Q and R would be so that we can figure out what this whole expression and that whole expression are. So just find the pieces that aren't already determined. P and Q, so we're going to take P and Q. If they're both true, then you're going to get a resulting true. Again, both true, resulting true. The rest, there's going to be at least one false element, therefore the rest of those will be false. And then we're going to take the P and R, or Q and R, and do the same thing. Both of these being true is going to be true. You can see that happens here and there, and the rest of those are going to be false. Okay, now we have the intermediate expressions. Now we can determine what this whole thing is. So we take the P and Q, whatever the results we had there, and then take an AND with the variable R and see where they have them both being true. You can see that happens in the first two cells, and the rest of them, there's at least one false. Therefore, the rest of those are going to be false. Then we're going to do a similar thing with the second expression. We have P, and then we're going to take that and Q and R. Again, we're going to find the first two to be both true, therefore we get a true, and the rest of those are going to be false. So that's going to be false. So then how do we answer this? Well, we're going to say they're both going to be logically equivalent because after working out the truth tables in canonical form, all corresponding members in the final two columns are identical. So because these two columns represent the original expressions and they are identical, first two being true and the rest of those being false, we know that these two expressions are always going to be the same, and therefore they're going to be logically equivalent.